Yeah, I'll wait 2 more minutes so that few more will join and we will start the class. Yeah, I think now three of you joined already. So let's start the class now. So later on remaining people can join. Yeah. mm, Hope three of you watched this week's videos. Did you all get chance to go through the videos? Sati, Shanti, Kavita, and Smita. All of you got chance to go through the videos? Okay, okay. This week, as you all know, there is not much content to prepare for problems, but don't worry. There were 3 weeks lectures where we saw few concepts like Faraday's law, then we saw Nernst equation, etc. So we'll reinforce the content there. We'll see more problems and we will try to reinforce the basics as well as the concept. New. So today I'll be delivering two things. First part will be mostly consider problems on. First one is Faraday's law. Second one will be measurement of potential. Basically, here we'll be seeing conversion between normal lab electrodes. What do you mean by that? Something like AgAgCl as well as Hg2 Cl2 bar Hg. So these kind of electrodes, we will see how we can, once we measure in the laboratory potential, how can we represent it properly for a publication or what is it on a public platform so that everyone can compare the data. Third part will be Nernst equation. So we'll solve a few problems based on Nernst equation. So finally, in the second part, I'll put it as one. The second part will see potentiometric titrations and few questions and a few questions. Should we start then? Yeah. Hmm. Which is it date completed or date coming up? Okay, not completed. Please do not ask me because it's uh, going for evaluation, right? So it's okay. So can you just give the question, but I want to answer it directly. Indirectly, I can answer. So what was the question? Hmm. Hmm. So you can form two half cells, right? Anodic and cathodic. So E cell is equal to E cathode minus E anode. Then is it given concentration? No problem. Concentration is low, right? So in dilute solution, you can equate activity to concentration. TL, TL or TI? Okay, so the problem you have to solve. Next week we will discuss the question after the deadline is over. Is that fine? No, no, that's I cannot do actually. That's we this year assignments we are not supposed to discuss actually. I'll be some problems, similar problems we will solve today also. You just go through that Nernst equation. I think I'm going to solve three, four problems today. So you just try. So this year question I cannot discuss directly. So what do you? You want the derivation? How? So for a reaction I have Daniel cell. How to write the Nernst equation you want to know? Hmm. Calculator in the sense? Okay, in exams I'm not sure about it. Is it like that? So let me check. I have the registration. So 1 second. Uh, Let me. If it comes fast, I'll just check. Otherwise, I'll tell you next week. So because I always do in my calculator, I don't check the because I'm not registered as a student, right? So I haven't checked the one. Let me check next week. What are your difficulty using log calculator? Is it law? What about others? Are you all able to? Are you all registered for exam? What about Kavita? Others? Others, are you able to use the calculator? Smita. So right now I cannot go to that window because my screen is recording. So whatever mail I am taking, it will come in the screen recordings. So I'll check once this week, then I'll let you know next week. So what about others? Are you able to access the calculator? No, no. She's telling you are supposed to use a calculator given in the website. So that Shanti was saying you are supposed to use a calculator given in the website. Is it? Mm, mm. Okay, there won't be problem. Yeah, yeah. Then Yeah, yeah, fine. Just write to the professor or NPTEL team so that you will get a clarity. I'm not sure about the exam part and all. So, Shanti, please write to the NPTEL team whether you can use a normal calculator in exam or not. I think you can because I don't think these calculations can be because log 1 by 10 raised to minus 5 is fine. Which one? Kavita is saying, so you are not allowed to use other calculators in exam. So is that so? Okay, okay. Just make it clear. Anyway, I am also logged in the registration form. So let me check the calculator and I'll come back to it next week. How whether log scale is there or not. Right now I am using my normal calculator. So for calculations. So let me check and come back. That's actually my role is to discuss the problems related to the topics. So I'm not part of really the part of the course. So I'm a research scholar from PMRF research scholar. So we are facilitating more problems so that you will get familiar. So exam, all those things you have to ask to the NPTEL team really. So those part I'm not sure and I'm not the person to answer on that, comment on that because. Hmm, hmm, hmm. Okay, okay, they will give like ABCD. But okay, but still, if you're asked to calculate something with log 5.67. Okay, 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 then fine. I think they will ask such questions only then, because if they also know without calculator something cannot be done, so they'll be giving problems like that only. That's logic. But you can make sure from NPTLT. Hmm. Hmm. And I think Aisar Mohali. You are telling about Ashutosh sir, who is taking this test? Okay, Aisar Mohali. Yeah. Hmm. Okay, then it's fine. Okay, okay. Let me once I that's better. You write to the NPTEL team. You have the mail ID, right? So just write that. Then one of you please mention that point in the next class because I am not registered for exam, so I won't be able to ask the question to NPTEL team. Okay, so one of you just write a mail, get a clarity, and please clarify in the next class. So others will be also benefited. Other students. Yeah, please do it. Dr. Manju, I think you can do that, right? You can write a mail to NPTEL, right, regarding this? Yeah, please, please. Then other students will also get a clarity. So anyway, here we will be describing problems which need calculator. You can use your scientific calculator. So we'll be understanding. So something you have to make sure like log 10 raised to minus 5 will be minus 5 into log 10. Log 10 is 1. So those kind of simple calculation we have to remember so that we can easily use those things. The properties of log, all those things. So that won't be a problem. Then another thing is Faraday's law. In that you can remember that Faraday's constant is 96500. Then you can, for easiness of calculation, you can take it 1 farad. Then do the calculation. Finally convert it into what you say, how many coulomb it's coming. So those kind of numbers you can remember. So that will be easy. Even though it's come questions like that, you can easily solve those things. So let's come back to today's class. So first topic I'll be covering today. We'll try to see how to conversion between reference electrodes. So in lab scale, most of us will be using two type of electrode. One is calomel electrode. Second one will be AgCl. How many of you know how to convert AgAgCl measurement into SHE. Anyone did this? ESH is equal to E0 calomel plus E calomel measured. I'm writing measured for this is measured value. Similarly, AgAgCl also we can write a similar equation. ESHE is equal to E0 AgAgCl plus E AgAgCl. This is also measured. So you can see there are two things, E0 AgAgCl and E0 calomel. So what are these values? So as you may have already seen in the previous class problem solving session also, in AgAgCl as well as this calomel electrode, the electrode will be immersed in a solution, KCl solution mostly. So according to the concentration of KCl, the value of E0 will be changing. E0 calomel will be equal to 0.241 volt if you use a saturated KCl. The value will be equal to 0.250 volt if you are using a 3.5 molar KCl. Sorry, 3.5 molar KCl, it will be equal to 0.280 if it is a 1 molar KCl. Finally, it will be equal to 0.334 volt if you use a 0.1 molar KCl. Similarly, we can tell here, so E0 AgAgCl will be equal to 0.197 volt if you use saturated KCl. It will be 0.205 volt if you use a 3.5 molar KCl and 0.288 volt if you use a 0.1 molar KCl. So is that clear? So what we are doing is whatever value we are getting in the tables are against SHE. So either we have to convert the value we are measuring in our laboratory to SHE or something called reversible hydrogen electrode. So that one we will see in the next. So why when we read a research paper or a literature, you will see most potential will be required against reversible hydrogen electrode. So that part we will see in the next one. So we'll just see a few simple conversion problems. Then we will move on to the remaining topics. So problem is first problem. We'll say convert the following. Convert the following potential. So A part is minus 1.4 volt versus AgAgCl filled with a 3.5 molar KCl to SHE. Can all of you try? What will be the value coming? So use the equation. Hope you have noted down these equations. So this part will go a little faster because it's very easy. So for familiarizing only, I am doing this. So what's the answer coming? So how can I convert? ESHE is equal to E0 AgAgCl plus EAgAgCl. So E0 for 3.5 molar is 0.205 minus 1.4. Answer will be minus 1.195 volt versus SHE. Is this clear? Yeah. So let's do the next one. So now try 0.63 volt versus AgAgCl filled with saturated KCl to SHE. What will be the answer? ESH is equal to, comment, please comment the answer once you are done. This part will move faster. 827 volt. Yeah, correct. Versus always write what is the reference. Then see next question. So we'll move it faster. 9.8 volt versus saturated calomel electrode to SHE. ESHE is equal to done. What will be the value? To convert SE into SE into SHE, we need a standard potential of 0.241. So what will be the answer? 0. Okay. The answer is 2.041 volt versus SHE. So one more SHE will do, then we'll move on. Minus 0.53 volt versus calomel filled with 1 molar KCl to SHE. ESHE is equal to what will be the value? ESHE will be equal to minus 0.25 volt versus. So why I'm emphasizing is when you are using AgAgCl or standard calomel or saturated calomel or other calomel electrodes, the potential will be depending upon the concentration of KCl field. So make sure when you convert the values, you are taking the correct value and make sure the solution concentration is also you are taking accurately. Fine. So even though when you buy it commercially also, you may be filling the KCl solution in it. Because KCl, the concentration tends to increase because liquid will evaporate and this KCl will to slice. So next problem is minus 0.9 volt versus saturated calomel electrode to AgCl filled with saturated KCl. So just to familiarize. So how we'll do? So we have two equations in the previous page. One is ESHE to E calomel and then ESHE to EAgHCl. When we combine these two, we will get E calomel is equal to E0 AgCl minus E0 calomel plus EAgAgCl. So we can use this equation, combined equation, to find the solution. So here we are asked to find out EAgAgCl, which will be equal to E calomel minus E0 AgAgCl plus E0 calomel. So what was the value? Minus 0.9 minus E0 AgCl, saturated means it's 197 plus E0 calomel is 0.241. So what will be the answer coming? Minus 0.856 volt versus AgCl. Is that clear? Similarly, you can try this problem later. 0.2 volt versus AgCl filled with 0.1 molar KCl to calomel electrode filled with 3.5 molar KCl. You can try this problem. So answer will be what is that? 0.230 volt versus calomel electrode. So now let's go to one more topic, which is all of you heard about reversible hydrogen electrode. All of you heard about it? What is reversible hydrogen electrode? Is it a real electrode? Any of you? Is it a real electrode? RHE. We'll give it as RHE. How do you represent the potential? If someone is doing experiments, how will you represent? Either AgCl, SHE. So there is one more scale called RHE. So here potential is represented in a way it is corrected for the pH of the solution, because the potential of a reaction depends on the electrolyte pH. How? Let's take a reaction like oxygen evolution reaction. Oxygen evolution reaction. So how can we write the oxygen evolution reaction in acidic media? Acidic media. How can I write what is the oxygen evolution reaction in acidic media? Any of you? What is the equation? How oxygen evolution happens? We have discussed it many times in during the lectures. What is the equation for oxygen evolution reaction? What is the equation? So in acidic media, it can be written as 2H2O gives 4H plus O2 plus 4 electron. Fine. So how will I write the Nernst equation for this? Nernst equation. Any of you? How will I write Nernst equation? We have learned it all the classes. E is equal to E0 plus 0.0591 divided by N. N is here 4 electron, 4 log of, what will you write? Concentration of H plus raised to 4. Yeah, Shanti, you're asking something? Okay, here I use plus because I am using it in the oxidation direction. Okay, so usually I use a reduction potential, so I used it in the oxidation direction. So here I used the positive sign. If I'm writing in the reduction form, it will be minus 0.0591 divided by 4 log of 1 by H plus concentration raised to 4. So in the next step, we can take out the one thing we missed. So P, partial pressure of oxygen. Oxygen. So I'll assume partial pressure of oxygen equal to 1 atm. Assuming that, we can go forward. We can write E is equal to E0 plus 0.0591 divided by 5 for log concentration of H plus raised to 4. So rearranging E0 is 0.0591 log of H plus concentration. Is it fine? So what is log H plus concentration? It is nothing but we can write E is equal to E0 minus 0.0591 pH. pH. Fine. So, what is the on P0 value for potential for this one oxygen evolution reaction? Standard is E0 is equal to 1.23 volt. So, how can we calculate this? So, at pH equal to 0, what we can write is equal to E0, which is equal to 1.23 volt. At if suppose pH is equal to 7, what will be the E value? What will be? Someone calculate. Can you calculate? At pH equal to 7, what will be the E value? What will be the E value? Cell potential. What will be the measured potential if I'm doing it in a solution of pH 7? How can I calculate? Just substitute the value 7 here. So multiply 0.0591 into 7 minus it from 1.23. Hmm? No, no. What? How? pH 7 means just multiply 0.0591 into 7, then minus it from 1.23. What will be the value coming? No, you took it reverse actually. You substituted that 7 value in log. Yeah, the answer will be 0.816 volt. Then suppose we are using a pH solution of 14. E will be similarly you can calculate. It will be 0.4026. So suppose three people are doing experiments and telling my reduction or oxidation is happening. One person is doing in a solution of pH 1, 0 is not possible. 1, he's saying it's happening at a potential of X. Then second person is doing at a pH of 8. He's telling it X1, X2, X3. So people will start claiming like my catalyst is better than the second person's catalyst. Like, so in order to avoid that, we will while reporting values, we will try to incorporate the pH effects and uh, represent it in versus RHE scale. So more details of this you can um, refer to something like Powerback's diagram or Powerbay diagram. I don't know how exactly it pronounces. So the pH effect and potential, those things are well explained in that. Since it's totally out of this course syllabus, I am not touching that portion. So understand this, the potential will be a function of solution pH also. So we will introduce something called standard reversible hydrogen electrode, which will incorporate the effect of pH also. So here we can write, suppose I am using some AgAgCl reference electrode in my lab, I can write ESHRHE is equal to E0 AgAgCl plus EAgAgCl. This is AgAgCl to SHE conversion. Then minus plus 0.0591 pH. So I'll write it in the next page neatly. So what is that? ERHE is equal to E0 AgAgCl plus EAgAgCl. That this is nothing but measured value plus 0.0591 pH. So we can use this equation to represent the measured potential against RHE. That is reversible hydrogen electrode. Now let's do a problem to make the concept more clear. Calculate the potential versus RHE if a reaction conducted in a solution of 6.6 into 10 raised to minus 8 molar concentration of OH minus ions records a potential of minus 1.9 volt versus Ag AgCl. Here I have to mention the concentration also 3.5 molar KCl. Can you calculate? So calculate the potential versus RHE if a reaction conducted in a solution of 6.6 into 10 raised to minus 8 molar concentration of OH minus ions records a potential of minus 1.9 volt versus AgCl with filled with 3.5 molar KCl. So what is given here? OH minus concentration is given, which is equal to 6.6 into 10 raised to minus 8 molar. Is the question clear? Or should I give little more hint? Is it clear or should I give start solving? So you have to apply a relation also here. So if it is clear, you can continue or I'll start solving it. So have you solved it? 3. What's the answer coming? Shanti? Okay. So I'll give one more hint. So what is pH? pH is equal to minus log of H plus concentration, right? Similarly, POH is equal to minus log of OH minus concentration. Then what's the relation connecting them? pH plus POH is equal to 40. Now, can you able to solve? Okay, let's do a little more. So what's given here? POH minus concentration is given. So I can calculate what is the value of POH. POH will be equal to minus log of OH minus concentration, which is equal to minus log of 6.6 into 10 raised to minus 8. So what will be the value coming? It is equal to 7.18. Then pH plus POH is equal to 14. Implies pH is equal to 14 minus 7.18, which is nothing but 6.82. So now the pH value is given. So ERHE is equal to 0.205 because it's 3.5 molar KCl plus 0.0591 into 6.82 minus 1.9. So the answer will be minus 1.292 volt versus. This kind of problems won't come in exams, but this is for, because here also you see we have applied Nernst equation to derive this equation. So many cases Nernst equation is the basis for whatever we are doing in the lab. Similarly, if I change OH minus concentration into 6.6 into 10 raised to minus 5 molar, what will be the answer? What will be the ERH value? ERH will be equal to minus 1.115 volt. This is RH. How it comes? Because the here POH will be equal to it's something 4.2 something it will come. So pH will be equal to 9.82. So substituting this, you will get the answer. Fine. Is it fine? Shall we move on to next question? So now we will directly come back to our normal form Faraday's law. Is it clear? Or anyone need clarification? Any doubts? Feel free to ask. If I know, I'll clarify right away. Otherwise, I'll clarify in the next class. Okay, then we'll move to this problem. I expect all of you will solve very fast. So, I'm problems may be coming like a real system, real battery or something. But don't worry, just go through the problem, capture the data given, and try to solve the problem. Okay. So the question is: A zinc bromine battery is charged at 20 milliampere current until 9,000 90,000 coulombs are passed. If the battery is discharged at 20 milliampere, how many hours it would last, assuming it exhibit 100 percentage coulombic efficiency. So here also I will give some hint. So you see here charge is given. After charging, it is discharged at a constant rate. So you have current as well as you have charge. So using these two things, we have a equation to relate. You can calculate the time required for discharge, full discharge. So please try to solve this. Let me know once you solve. Are you able to solve? It is direct calculation. Shanti, Trying, okay. So what's the equation? Charge is equal to current into time. So use this relation rather than large Q, I'll use small q. Q is equal to IT. No, no. T is equal to 4500. No, 4500 means there is some mistake happened. Let me check. 4500 seconds you told, right? There is some part missing. So 1000 is missing. Current is given in milliampere. You have to convert it into ampere. That's the SI unit. Somewhat answer is correct, but you are missing few zeros. So how will you solve it? So I'll reduce the numbers to small values given charge. At the time of discharge, starting discharge, charge is equal to 90,000 coulomb, right? So I'll just divide it by, yeah, that is correct. So I'll just convert it into ampere hour for that 90,000 divided by 3600, which is nothing but 25 ampere hour. So how can I, time of discharge is equal to uh, 25 ampere hour divided by 20 into 10 raised to minus 3 ampere. So ampere cancels out. Answer will be 1250 hours. So if you convert it into seconds, that big value will come. So I just converted it to hours. Then I did. So here you see I have used 100% Coulombic efficiency. So I'll just give a B part to this question. Same question. If the battery was discharged at 30 milliampere with a Coulombic efficiency of 75%, how how long it would lasted. So I just changed the discharge current. Then Coulombic efficiency is also lesser. So how can I solve this? So discharge time. So calculate in hour. That will be easy. What's the answer? Which is equal to 25 divided by 30 into 10 raised to minus 3. I'll multiply it with 0.75 because it will take longer time, which is equal to 625 hours. Six, two. Is it clear? Is it clear to everyone? Sri Suyambilinka, Shanti, then others. So I'm not only seeing two or three on the screen. Karan, Kavita, Smita, is it is this problem clear? So it's just direct application of Faraday's law. Instead of directly giving numbers, I just give a practical battery, which we work on. 25 refers. Okay, 25. Okay. So you see, what's the value given here? 90,000 coulomb, right? So what is coulomb? Coulomb is nothing but ampere second. Q is equal to I into T. So this is coulomb, which is nothing but ampere into second. So I just want to convert it into some other unit, which when you buy a mobile phone, we will say battery capacity is 3000 mAh or 5000 mAh. So similarly, I just converted. So I can write 90,000 ampere second. So second, I want to convert it into hour. So I will write 90,000 divided by 3600 ampere hour. Because I will divide it by 3600, seconds will be converted into hour. So this value will come 25 ampere hour. So that, so what is here nothing but Q is equal to IT. So I want to find out T. So T is equal to Q divided by I. That's it. So the unit of Q I am taking here is ampere hour. I am taking as ampere. So ampere cancels out. I will get the answer in hour. Clear? Yeah, fine. So now let's move on to the next question. So the next question, this is a conceptual question. So apply your thermodynamics concept, you will get the answer. So consider the following. Q. Consider consider the following reaction. What is that? 10H2 plus 5O2 gives 10H2O. Here given E cell is equal to 1.23 volt. Calculate delta G in kilojoule. Hmm. Calculate delta G in kilojoules. So can you write the anode and cathode reactions? Reduction, here oxidation. What is the anodic reaction? Anyone? What is the anodic reaction, Bhavani? H2 gives 2H plus 2 electron. What is the cathodic reaction? What you're asking? H or H plus. What is that? Sri, you're asking something. Okay, Bhavan, you continue. What is the cathodic reaction? Okay, okay. What can you speak? I couldn't understand your question. Anodic. At anode, we have oxidation. Here, hydrogen will give H plus plus electrons. Yes, yes. Yeah, anodic. What will be the cathodic reaction? It will be okay. So it will be 2H plus half O2 gives H2O plus 2 electron. So the overall reaction you can write H2 plus half O2 gives H2O. Is it fine? So here what is the reaction given? Here it is 10H2 plus 5O2 gives 10H2O. So think about it a little and try to find what is delta G. We have the equation for delta G, right? What was the equation? Delta G? Delta G is equal to minus NFE. So please solve it. What will be the answer? Come again. What is the answer? Shanti? Answer. Values are correct, but decimal points have some problem. So how many electrons are involved here? N is equal to what? E is given. F we already know. E cell is given 1.23 volt. F is equal to 96485 coulomb. So what is the value of N? What is the value of N? Yeah, N is 2. How? That's Shanti already commented. Delta G is an extensive property. Is an extensive property. It will depend on quantity. How? Because delta, what is delta G? Delta G is maximum possible work. Possible work. So, if the matter, matter is quantity, matter in the system increases, the maximum possible work will also increase. So here you see, for one water molecule, we need two electrons. So here we produce 10 water molecules. That implies we need 20 electrons. So if you substitute that, delta G is equal to minus 20 into 96485 into 1.23. What will be the answer? So that's why I put specifically this question. Delta G is a extensive property, so it will be also depending upon the quantity. So here you have to take N is equal to 20. So please calculate and tell the answer. But Shanti commented was almost right, 237.4 kilojoule. Since someone commented different answer, I so once again calculate 20 into 96485 into 1.23 divided by 1000. Right? I'm also getting the different answer. 1 second. What's the answer coming? Anyone? Have any of you tried? Okay, my answer was wrong. The answer is coming. I just calculated. So 237, oh, sorry, 2373.5 kilojoule. So I missed a digit. Is it fine? So I think now Faraday's law, any questions, all of you should be able to answer. Any region, if Faraday's law's question comes, you should answer if it is related to delta G as well as equilibrium constant. So I hope that portion is very clear to you. All of you will score full marks in that portion. So I have asked questions which are relatively easy, but still you have to think a little to take out the values. So now we'll go to the Nernst equation part. So one thing I want to tell you, for a dilute solution, the activity can be equated to concentration. So consider this because the problems I will be giving, the molarity will be low. So you can equate the molarity, so activity to concentration and do the calculations. So question is, calculate the potential of silver electrode dipped in 0.1 molar solution of silver. 1 second, sorry. Silver nitrate solution at 298 Kelvin. Assume silver nitrate is fully dissociated. Given E0 Ag plus bar Ag is equal to 0.8 volt versus SHE at 298 Kelvin. Can you try to solve? Direct question. Give me a minute. I'll just come back in a minute. So any query means please put it in the comment. So, Shanti, the answer, there is a small mistake. I think so. So, how did you calculate that? So, what is the reaction happening here? So, redox reaction, Ag gives Ag plus electron giving Ag, right? So, how will I write the Nernst equation? E is equal to E0 Ag plus bar Ag minus 0.05 since 91 divided by 1 log of 1 by concentration of Ag plus. Since the temperature is 298, I am directly converting it and taking. So what will be? It will be equal to 0.8 minus 0.0591 into log of 1 by 0.1. So it is nothing but log 10. It will be equal to 0.8 minus 0.0591 log 10, which is nothing but 1. Equal to 0.8 minus 0.0591. Answer is equal to 0.7409 volt. Is that clear? Yeah, Bhavani. Okay, okay. Shanti, are you clear about the problem? I think you have taken plus there. That's it. No, it's okay, okay. Hmm. No, no. 1 by point 1. You can directly write point 1 there. That is nothing but 10 raised to minus 1. But it will be 1 by 10 plus 1 by 10 again. No, no. It will be minus because it goes up. 10 raised to minus 1 means nothing but 10. You have taken 10 raised to minus 1 as well as took the minus sign out. So just need to be careful. That's it. Next question. Same question. At what concentration of Ag plus ions this electrode have a potential of 0 volt. So it's just same problem. At what concentration of Ag plus ions this electrode have a potential of 0 volt. Here we have to calculate concentration of Ag plus. What's the answer? So how will you solve? 0 voltage is given 0. 0 equal to 0.8 minus 0.0591 log of 1 by concentration of Ag plus. We have to find out at what Ag plus concentration the cell potential will be 0. So I can write log of 1 by concentration of Ag plus is equal to 0.8 divided by 0.0591, which is nothing but 13.536. Then from that we can take anti-log to the base 10. Ag plus is equal to 2.91 into 10 raised to minus 14 molar. Clear? Oh, sorry, 40. I missed 10 raised to minus 40. Thank you. Shall we move on to next question? So next question is a zinc rod is dipped in 0.1 molar solution of zinc sulfate. The salt is 80% dissociated at this dilution at 298 Kelvin. Calculate the electrode potential given E0 zinc 2 plus bar zinc is equal to 0.76 E0 please calculate.
ഇതിനെ പറ്റി സംസാരിച്ചായിരുന്നു. അപ്പം നോക്കാന്ന് പറഞ്ഞിട്ടുണ്ട്. ഞാൻ പതുക്കെ നോക്കാം കേട്ടോ. ഉടനെ ഇതാക്കില്ല, കുറച്ചുകൂടെ പതുക്കെ ലിറ്ററേച്ചേഴ്സ് ഒക്കെ നോക്കി തുടങ്ങാം.
What's the answer? Sorry, I was muted. What's the answer? How will you solve this? We have E is equal to E0 7 2 plus 7 minus 0.0591 divided by N. N is here 2 log of concentration of zinc divided by concentration of zinc 2 plus. So here what happens is minus 0.76 minus 0.0591 divided by 2 equal to minus 0.76 minus 0.0591 divided by 2 log of 1 by what will be the zinc concentration here? What will be the zinc concentration? Look at this point. 80% dissociated. Then what will be the zinc concentration? Yes. 0.8 into 0.1, nothing but 0, sorry, which is nothing but 0.08. So when you solve, the answer will be minus 0.7835 volt. This is SHE. Is it clear? Is that clear? So we'll solve one more problem from Faraday's law and finish this portion, and then we will go to the volumetric titration, because I don't have much problems in that, because this week and there things were videos. So I hope everyone saw that videos and understood. So the videos was straightforward, and you have, I'll show the Excel calculations once if someone have any doubt. So last question, don't be scared about the question line. So I just want to introduce the concept of lithium ion batteries. For that, I just made a problem. It's very easy, but the concept will be delivered. So consider this question. Lithium, cobalt, oxide, which is LiCOO2, or we will call it as LCO simply. LCO is a cathode material in lithium ion batteries. During charging, lithium, during charging, lithium in the cathode will go to anode and get intercalated between graphite layers. Graphite have a van der Waals layers, so it will be get intercalated in the graphite layer. Note that, note that it is not possible to extract more than 50 percentage, more than 50 percentage, or I'll write it in a better way, more than 0.5 mole of Li from each mole of LiCOO2. Calculate the theoretical capacity of the battery in milliampere hours per gram with LCO as cathode. Given molar mass of Li, cobalt, and oxygen are 6.94 gram, 58.9 gram, and 15.99 units respectively. So, all of you understood the problem? It's a long question, right? So I don't ask you to solve it. I'll give the theory directly. So it's direct Faraday's law, but the thing you have to understand is lithium ion battery is something we discussed a lot nowadays. So for every battery, there will be a cathode and anode. There are many cathode material which we people use in lithium ion batteries. One of them is called lithium cobalt oxide. So it is a cathode material. Graphite is a very known anode material. So I'm taking LCO as cathode, and graphite as anode. Okay. Here what happens? Lithium cobalt oxide, what is that? LiCoO2. It has lithium. During discharging, during charging, what happens? Lithium in the lithium cobalt oxide will leave the material, lithium plus. It will goes towards the anode where electrons goes through the external circuit, and it will get the term you note intercalated to the graphite layer. That's a reaction. So what's happening? Lithium will give lithium uh, 1 minus X cobalt oxide plus 1 minus X electron plus 1 minus X lithium. So this is one more point. Lithium, all of your, I hope you all of studies chemistry. So some material, if you try to take more of lithium, what happens? Structural collapse will happen because in this type of material, we cannot take more than 0.5 moles of lithium per mole of lithium cobalt oxide. So maximum capacity. So the equation you can write LiCoO2 gives Li 0.5 CoO2 plus 0.5 electron plus 0.5 lithium. So what will be the capacity in milligram, milliampere hour? So here, what is the charge of 1 mole of electron? What is the charge of 1 mole of electron? Shanti, 96500. So what is the value corresponding in ampere hour? Lavanya, we calculated, right? We divided it by 3600. So what will be the value coming? 26.8 ampere hour. Right? Remember, right, everyone? Bhavani, is it clear? So 1 mole of electron is corresponding to 96500 or 96485 coulomb, which is equivalent to 26.8 ampere hour. Here, how many electrons are involved in this equation? How many electrons are there? How many electrons are there? Anyone? Yeah, 0.5. So 0.5 mole of electron. What will be the charge in ampere hour? What will be the charge? 13.4 ampere hour. So is this clear? Clear, right? So in real work and all, we will be representing it as a function of mass of cathode material used. That's why we ask what is the capacity in milliampere hour per gram. So how will we calculate that quantity? So we'll calculate molecular weight of LiCoO2. For that, what is given? The molar mass of lithium is given, cobalt is given, and oxygen is given. So we'll write which is equal to 6.94 plus 58.9 plus 2 into 15 point, what was the value? 98, right? 99. 99. So this value will be equal to 97.8 unit. So how will I calculate milliampere per hour gram? 13.4 divided by 97.8. So the capacity will be coming how much? 136.986 milliampere hour per gram. So this is a theoretical value when you are referring to any research papers and all, they will be representing LCO theoretical capacity will be 136.986 milliampere hour per gram. Is it clear? So this don't worry about it. This kind of concept, these kind of questions, I don't think will be coming for exam. But just think, this is the concept. 1 mole of electron is 26.8 ampere hour, which is nothing but 96500 coulomb. So using that, we can do any calculation. Since the question was asked in ampere hour per gram, we just calculated the weight of active material and divided it to get the value of capacity in milliampere hour per gram. Okay, we'll see a little theory and we'll just wind up today's class. So what was the discussion in last week? So it was potentiometric titrations. So what was the first type of combination? What was the first potentiometric titration? What was that? Acid-base titration. In that, first one was strong acid versus strong base. So how does the curve? So we have taken example HCl and I think N by 100 something like that. Then NaOH N by 10. So initially the standardization using oxalic acid was done to find out the concentration of the normality of NaOH. So how does the curves look like? So the qualitative curves will be, first we'll plot pH versus VNaOH. The curve will be for a strong acid versus base, it will be like this. Then the second plot was delta pH versus VNaOH. It was a pulse like thing. It will be coming like this. It will be like, so this point you can write it as neutralization point. The volume corresponding we will take it as volume of NaOH required for neutralization. Then what was the second type? What was the second type of titrations? What was that? Weak acid versus strong base. So the plots will be pH versus VNaOH delta pH. So here it won't be that straight, it will be little tilted. Then we'll be having this up going, then it will be little sorry. It will be around 10 to 12. Then similarly here also, not this much, but still fine. Similarly, you will get the V. What was the third part? What was the third type of titration? What was that? Weak dibasic acid versus strong base. What is the example for this weak acid versus strong base? What was the examples seen in the class? Is that strong weak acid versus strong base? Oxalic acid is a dibase, right? Diacid, right? No, not dibasic acid. One second. Miss something, I think. So what was the weak acid versus strong base example? When I'm searching something else. What was that? It was acetic acid CH3COOH versus NaOH. In this case only, we have seen carboxylic acid COOH, that is oxalic acid versus NaOH. How was the plots? I will draw small. Here pH versus VNaOH. pH you should not write like that. While writing pH, small p and capital H. So how will the plot? So initially you have a small upward portion, then it will go like this. Again we have upward portion like this, go like this. So mine, so we have two values. From this value we will get pKa1, that is dissociation constant 1. Similarly, from here, this this is V1, this is V2. So V2 minus V1 by 2 will give this value. So this will be the pKa2, that is dissociation constant. Here also you can do similarly. V by 2. So this is pKa, that is dissociation constant. Similarly, the second plot also you already know, so I'm not touching that. So these are the portions, detailed titration methodology you have seen in the videos. So let's see some simple problems. After that, I'll just show the Excel sheet how the problem has been solved. So the question is, in a potentiometric titration, the endpoint is obtained by observing. What was we were doing? How we are finding out the endpoint? Was that increase in current? Was that increase in current, Lavanya? Yeah, yeah. I thought we'll take point by point. It's fine. So we will see adding slowly NaOH and seeing the change in pH. So when we had a small change and a sudden increase, we were seeing the endpoint. So the option is sudden increase in pH. Is there any change in color? We are not using any indicator like normal first iteration we have seen. We are using phenolphthalein indicator. So it's not change in color. It was not change in turbidity as well. So the amount of crystalline, next question is the amount of crystalline oxalic acid required to prepare 250 ml of N by 10 oxalic acid solution is. How can we? No, we want N by 10. So how can I prepare one? Yeah. How will we prepare one normal solution? How much we need? 63 gram. So it is oxalic acid dihydrate. That is nothing but oxalic acid dot 2H2O. So the molecular weight is, I think, 126. Since it is oxalic acid is uh, what you say, you can write COOH. COOH gives COO minus COO minus plus 2H plus. So since it's 2 is coming, we can write equivalent weight is 126 divided by 2, it is 63. So equivalent weight is 63. That means to prepare one normal solution in 1 liter, you need 63 gram. So for preparing what is saying 250 ml, you can divide for preparing a n by 10 solution, you can divide it by 4. 6.3 divided by 4. So how many grams is required? 6.3 divided by 4. 15.75. So is it clear? I think I made it confusing. So 1 liter, 1 normal solution, you need 63 gram. So for 1 liter, for zero point 0.1 normal solution, you need 6.3 gram. Here we don't have 1 liter, you have only 250 ml. So you just need to 6.3. Yeah, yeah, 10. N by 10. N by 10 is nothing but zero point 0.1 normal. So it's just when you calculate for the experiments and all, it will be useful. So similarly, you can calculate for molarity also. Molarity. So next question is, all of the following statements are correct regarding the potentiometric titration except potentiometric titration is suitable for colored or turbid reactions. Is it true? Is it true? No, no. The cell EMF, one second. The cell EMF, the second option is it correct? First option is correct. The EMF of the cell is zero at the equivalence point. Is it true? Is it true? It is not true because have you seen? Just go through the video at the equivalence point or that is it voltage showing zero? Yeah, minus or positive, it will be depending upon. So it's not zero, right? So the next option is this is not suitable for analysis of dilute solution less than 0.001 molar. What happens if less than 0.001 molar solution? The concentration is too low. The equivalence point will come very early. Even you have to, when you add very small, it is not possible by the means we have seen in the class. So this is also correct. So liquid junction potential will not be influenced in this study. Is that correct? When liquid junction potential arises, LJP. When liquid junction potential arises. Yeah, I have different C1 concentration, C2 concentration separated by a wall. When I remove that, what happens is if I have HCl solution on both part, the ionic mobility of H plus and Cl minus are different. H plus can travel faster. So due to that suppression in charge, in the instant, liquid junction potential arises. Here, since we are adding neutralizing agent, here liquid junction potential will not appear, will not come into picture. So this option is also correct. So the answer is the EMF of the cell is zero at the equivalence point. It is not true. Clear? So I'll see the last question. Which among the following is expected for the potentiometric titration of H2SO4 and NaOH? Which will be the plot? H2SO4 is a strong or weak? Strong or weak? H2SO4 is a strong acid or weak acid? It is a strong acid. So for a strong acid, which will be the plot? pH versus volume of NaOH. Which one we can expect? A, B, C, D. 1, 2, 3, 4. Here, 1 is missing. 1. This is 2. Okay, it's there. Option A is the correct answer. Why? For a strong, yeah, for a strong acid, it will be very straight here. Then we have the neutralization, a sudden increase, then it again stable. This is pH, this is volume of NaOH. So option A will be the answer. So this week's class was relatively easy. That's why I tried to reinforce the previous topics. So now I'll stop sharing here and I'll show the Excel calculations once. All of you understood how the Excel calculations are done? All of you. Have you gone through the video? Is there any doubt in the Excel calculations? So I'll just stop sharing in my iPad. I'll share from here. The share screen. Yeah. Which one? Fourth question means assignment which we are going to submit, right? Uh, Assignment which are not submitted, I cannot explain. Yeah. Next week, if you have doubt, I'll just check the question and we'll explain in the class. What's the last date for assignment for? 21st. So after that only I can. 21st is tomorrow, day after tomorrow. Yeah. So I'll try to share from here. I haven't seen the question. That's why this year questions I haven't seen. So what is the type of question? Which is Nernst equation? Okay, okay. I have to check. Anyway, next week we will discuss that question. Today I haven't seen the question, and second one I'm not supposed to discuss that part. Did all of you tried this at home, or even though you haven't done the experiment, have you tried the calculation in Excel? Did you understand how these dotted lines came? All of you, I can't see any of you. So yeah, is it clear how plotting has been done in Excel? Yeah, yeah. Actually, there are two data. What I did is I just took the data what Sir was sharing in class. So initially we have volume of NaOH. What we were doing, Sir was adding zero point 0.02 ml and he was measuring the pH. So what we have from the experiment is volume of NaOH and pH. So from that, how will we calculate? So let me copy these two columns. Control C. I'll put it in a new. Okay. So how will I plot? Just select it entirely. Just go to insert, point plots. Done. So this is the plot. So after that, we'll just click on the points, right click, add trend line. So we'll use a moving mean. So second one is we have to plot delta pH versus OH, right? So for that, we have to calculate delta pH. How will you calculate delta pH? So we want to calculate, insert, symbols, delta, delta pH. So delta pH is nothing but you can do this value minus this value. So then we'll just drag it. So we got all the values. Then since the number of rows and columns should be equal, we'll just paste it here. Since the values are very small, what we'll do equal to this value into 50. We'll get a value like this. And again we'll drag it to here. Now we'll just, yeah, is the screen shared? Is it visible now? Is it my screen visible? Can you see my screen? Okay. Is it visible my PowerPoint? Okay, sorry. Let me try to share. Stop sharing. Share. Entire screen. Select. Share again. Is it visible now? My screen? Am I sharing my screen now? So, uh, okay, okay. Excel. Now is it share clear? Excel. Is the Excel? Okay, okay. So what I did is we have the VNaOH versus pH data. From that, let me come back. So we will calculate delta pH. How we will calculate delta pH? So this value minus this value. Yes. Then we will drag it. Then similarly, this column also control shift down. You'll get all the data to be copied. Control B. Just to what you say, make the big numbers big. We will just multiply this value with 50. That's what done in the video. Then we will again drag it till the end. So we will get the two values. Now we have delta pH and E value. So we'll select it. Similarly, select these values as well. Then again go plot. Now you have to go to trend line, add trend line, select the moving mean. Then you can see here the maximum is coming. So what is the value? 1.26. Using that value, you can calculate what will be the normality of HCl. Is it clear? So if you go to chart design, you can add axis titles. What is that? Y-axis is, x-axis is V, NaOH. You just give it as O subscript. Okay. Then similarly, go to chart design, chart title, vertical axis. What is vertical axis? Here, what is the vertical axis? That is, what is y-axis? What pH or delta pH? Delta pH. So we'll just write delta pH. Then chart title also we'll edit as what it. So insert symbols delta. Most of you will be knowing that. If someone have any doubt, I'll just showing pH versus V NaOH. So O O subscript. Okay. So we have the plot delta pH versus VNaOH. Is it clear? All of you understood how the calculations are done. So you might have some, not all of you, some of you might have doubted how the value that dotted lines came. It is nothing but we are taking a fitting. It is called fitting. So when we have multiple experimental points, we'll try to fit it with, sometimes we'll try to fit it with a straight line. Sometimes we'll try to fit it with a logarithmic scale like that. Is that clear? So this is the one we sir was demonstrating for HCl versus NaOH. Similarly, the acetic acid versus NaOH can be also done. So here also the maximum point is coming around here, which is nothing but what is the value coming? Is I think 1.5. So using that we can calculate what is the normality of HCl. Is that clear? So I'll try. I think I don't have a provision to share this Excel sheet. Let me check if there any possibility. No, don't worry. I will share this Excel sheet with the. We have a folder for what is it? Sharing the content, right? I will share this Excel sheet. You all of you can try with the data, plotting all those things. Is that fine? No, no. You just see this is the point maximum, right? Delta pH. Yeah, that's it. When I just put the cursor, it's showing 1.5. X value is 1.5. So I took it. Fine. So fitting actually, when we do the experiment, we won't get a very beautiful thing like what we are showing in paper. So we will be having a little up and down. It's called error bar. So we'll be doing multiple experiments. We'll take for each point, we will taking multiple values and take an average. In that case, it will come as smooth. It's since it's coming from a single data, it's lifting up and down. So from that, we will take a maximum value. Usually we have to fit it. Whatever point this point is coming maximum, we have to take it. From here, it's almost same as 1.5. So it's fine. Got it? So I'll try to share this Excel file also in the folder. So you'll be having this nothing but in the class servers showing the Excel. I just typed it out from that Excel form. So just to show you how to, if anyone have a doubt, that's why I just took it. Fine. Any other doubts? I'll just stop sharing here. So let's wind up today's class. So hope all of you are comfortable in Nernst equation and Faraday's law now. Okay, hope all of you can solve the problems. So one suggestion I'll give is uh, don't confuse with the notations. Try to write either the equation in oxidation or reduction form. If you take in oxidation reduction form, it will be E0 minus 0.0591. If you take it in the oxidation form, it will be plus 0.059 log of concentrations. Okay, don't confuse with the notations. Try to stick to a one notation. Whatever notation you take, the answer will come the same. So don't worry about it. Try to take simple systems like single electron process. Example, silver. Silver Ag plus plus electron give Ag. Two electron process. Example is zinc, copper, etc. Three electron process. Example is aluminium. Like that, take examples and try to solve. And similarly for the reference electrode, HG, Hg2Cl2, then Ag, AgCl, these things, how the Nernst equation is derived. Try to solve those. It will enhance your knowledge also. Once you solve again and again, you won't make mistake. Try to solve it in two ways. Initially, try to write the overall equation, overall reaction, and try to write the Nernst equation. Secondly, try to write half cell reaction and try to derive the Nernst equation. Compare these two and check whether you are getting the same answer. Then Faraday's law, only one thing, charge of 1 mole of electron is 96485 coulomb. So for some problems, you may need to consider the ampere hour unit. For that, you have to divide it by 3600. So you will get 26.8 ampere hour. This is the only concept you have to use for Faraday's law. So you can also write like weight is equal to electrochemical equivalent into IT. You can do in that way also. In that case, you need to be delivered with the electrochemical equivalence, or you can directly write relate the charge to weight using the analogy. So one chemical electrochemical equivalent or chemical equivalent to for zinc, for example, 65 point I think 65.36 gram is deposited when 2 electron is passed. Similarly for silver, I don't remember the value, so let it be. So like that for lithium, 7 gram is deposited when 1 mole of electron is passed. Similarly, like that also you can directly relate and write the equations. So let's wind up today's class. Next week we will see with some more uh, new topics. So all of you try to solve the assignment. If you are not been able to solve, let me also go through the questions and I'll try to solve the answers as well. So okay, everyone. Bye. See you next week.